May I request Swapnil from Infosys, and maybe Ajay, he can answer some of your questions that you posed him earlier. So I'll give it to Swapnil.
Yeah, I can just ask questions and see.
We would want to know when Infosys is going to build buildings like this.
Yeah.
Let him handle that.
Since he wants us to ask questions.
So I'll be very honest. The presentation that I'm using is yeah. So the presentation that I'm using is a result of. So we also talk a lot about sustainability to our customers, right? So in the morning when I came to know that I have to speak about Infosys efforts on sustainability, I grabbed a few slides and put it here. So it might not be really a complete story of what we do at Infosys, but nevertheless, I try and make an attempt. We are a carbon neutral company, so if that if that sets the context. We started our journey in 2008. And the real estate footprint for Infosys is close to 51 million square feet worth of built space. Right? We are talking about 16 different locations in the country with an employee strength of close to 3 lakh employees. The development center that I am a part of, where I am based out of, is Pune, and Pune boasts of 61,000 employees. The campus size is 313 acres with a built-up area of 3.03 million square feet worth of space. We have 14 buildings within the campus. We have 4 food courts. We have what we call as employee care center, which has 1,000 beds. So it's a hotel in itself. We have sporting facilities. We have state-of-the-art gymnasiums. We have bowling alleys. We have hospitals. We have transport bays. So we are a city in itself. And if you look at Pune as a campus, and if you try and replicate it across to any of the Infosys campus in the country, it will have all of these facilities, right? So when we talk about Infosys' sustainability journey, or when we talk about built environment, or when we talk about interventions that we make in the built environment, we are talking about any campus that's present across, in the country. The business model for Infosys since whenever it was conceptualized has been linear, right? You had number of people, the more people, the more revenue you have, right? And that growth got us 30% growth year on year, and that has now changed, right? 2008 is the time when we realized that essential, our services were also a function of the amount of energy we consume, the amount of water that we consume, and the amount of waste that we generated. So our founders set us up on the path for sustainable future, essentially, and it was primarily their vision which got us looking at how our campuses could be sustainable and how we could essentially get to net zero. So 2008 is when we started benchmarking all the resources that we consumed, and the resources that we consumed were primarily around energy, water, waste. We also looked at aspects around biodiversity because Infosys constructs beautiful campuses, right? In 2011, we made a voluntary commitment to the UN to be a carbon neutral company by 2020. And while we made this commitment, in 2012, we were the first company to have implemented radiant cooling technologies in our buildings. Now I'm going to take a step back and get a little technical for the engineer that I am. And this will probably answer the questions that were asked earlier. Our buildings consume a lot of energy with respect to air conditioning, right? So if you look at an Infosys building, the footprint is approximately 5 lakh square feet worth of built up space, which houses 5,000 people. So so 100 square feet per person is an average metric that we have. So if a building is 2 lakh square feet worth of space, it houses 2,000 people. So the entire design that is done for our buildings are taken into account looking at the 100 square feet. We realized that air conditioning was a big aspect, in the way in which we were operating the buildings. That is where we started looking at radiant technologies. Now, when you talk about radiant technologies, what we did was we split the cooling loads into two. We split sensible and latent loads. Latent loads was taken care by the conventional air conditioning that exists today, right? Which essentially made use of low temperature chillers, and all the sensible cooling was taken care of by medium temperature chillers. So the amount of water that we had to essentially cool from an ambient temperature to what it is needed to cool the building went down drastically, and it was roughly to the tune of 40-45%. That was a straight incremental saving in the amount of energy that we consume to cool our building. Now when we started cooling the building with air than with water, because then we had split these loads, this energy consumption further went down. So if you just look at, and when I was here the last time, I did show a comparison between two buildings in Hyderabad. SDB1, we call our buildings as software development blocks. SDB1, which has half of the building, which is a conventionally cooled VRV building, and a radiant building, and for the last 8 years, we have been comparing the energy savings that it has been given. So we were able to achieve close to 60% worth of energy savings as compared to a conventional building. Since 2011, the mandate, the strategy has been that we construct buildings that have radiant cooling technologies. So we've piloted direct indirect evaporative cooling. We have looked at using the most effective VRV systems. We have looked at using different kind of chillers. We have looked at what is it that so all of that. In 2013, we were one of the first companies where we published our business responsibility report, because that also ties back into the ESG agenda, if you will, because governance also happens to be one of the critical focus areas for us. We were the first IT company in 2014 to publish a GRIG4 comprehensive report. 2015 was when we made our commitment to be the first signatory to the RE100 program, where we said that 100% of our electricity will be sourced from renewable energy sources. On the social aspect, there are funds, a US $250 million fund for Innovate in India to help startups, the Dow Jones Sustainability Index, and so on and so forth. The icing on the cake was when we were a carbon neutral, and I'm going to talk about numbers in a while, was when we became a carbon neutral company in 2020, and we were awarded the 2019 UN Global Climate Actions Award. Multiple awards to our credit, but we did not stop at 2020, right? We then drafted what we say as our ESG vision for 2030. Now, I go to a lot of places and speak about ESG and what is it that we have done for ESG. And then there's a question that is asked of me, what do you think is the future of sustainability? Or what do you think is the future of ESG? Truthfully, for me, I do not have visibility for more than 10 years. We do not know how sustainability and ESG will pan out after 10 years. However, there are a set of 5 different levers or factors that will essentially influence how sustainability will pan out, right? And it is to do with policy, it is to do with innovation, it is to do with research and development, it is to do with technology, and it is also to do with human capital. So discussions and forums like these, which essentially engage and articulate thought leaderships around what we need to do from an ESG are important. Going back to what Infosys did, we said that we will continue to be carbon neutral across all the 3 scopes. We will further reduce our scope 1 emissions by 75%. We will go ahead and reduce our scope 3 emissions by 30%, and we will ensure that we continue to engage our clients on actions related to climate and climate change. Water is, and I'm going to talk about numbers in a while, we will have 100% wastewater recycling as one of our goals, and then there will be zero waste to landfills. There are a few other aspects around the ESG as well. So if I look at, and there are a lot of numbers here, right? So when we started our journey around energy efficiency, right, the metric was per capita energy consumption, right? 2008, the only work that the infrastructure team or the team that I come from did was put energy meters across our campuses, because we realized that data was important for us to make decisions. And we also realized that is that 2 minutes?
Yes.
Okay. We realized that if you torture data enough, it will confess to anything, right? And if you really respect that data, it will give you insights that will essentially help you make a lot of interventions that will essentially help you be a carbon neutral company. We've been able to reduce our per capita energy consumption by 54% over a 2008 benchmark. We realized that water was an important commodity during our journey towards net zero. We've reduced our per capita water consumption by about 59%. We have zero waste to landfills today. 91% of our single-use plastic has been reduced in our campuses. We have 60 megawatt worth of solar plants, captive solar plants that we've installed at Sira. We have another 7 megawatt in Hyderabad. Each of the campuses close to, on an average, 1.5 megawatt worth of solar that we have installed. We address to 11 SDGs out of the 17. In our journey. We've been able to ensure this because we have our campuses that are intelligent, instrumented, and interconnected, and these give us data at any given point in time. All our buildings today, close to 160 different buildings across 16 campuses, are LEED Platinum certified. Pune campus happens to be the largest existing building, LEED certification, Platinum rating across the world. Another metric is on a 2008 benchmark baseline, while our employee strength grew 100% or 166%, the absolute energy consumption just went up 20%. And this was because we had projects around energy efficiency, we put in renewable energy projects, and we also looked at projects around how do we offset the remaining things. Now, we do not stop here, right? Again, use data, so put in command centers, looked at aspects around decarbonization, democratization, and digitalization, right? And we realized that for people to achieve the benefits of decarbonization, we had to ensure equitable access of all of this to the society, and that's where the social aspect comes in as well. Again, some projects here. We run 9 carbon offset projects, right? We do not buy these projects. These carbon offset projects are primarily around rural electrification programs. So we had rural electrification that was done in villages in Kargil. We run cook stuff programs in Udaipur and places like that. We have construction of biogas plants across the country, and then we also look at ways and means in which we support the local art and culture that also essentially contributes to lowering the carbon footprint of the communities at large. The idea is to create resilient communities. Infosys Mysore campus is where the journey of any Infosys employee would start, right? So we actually have a university in Mysore, and we've converted Mysore as one of our shining examples of what a smart city framework should look like, what a smart sustainable city should look like. And this was something that we did when we presented to the Niti Aayog on what are the components that essentially need to go in if you have to create a smart city, right? And this was way back when the Smart Cities mission was essentially formulated. We look at environment, mobility, waste, wellness, water, look at a whole bunch of innovation strategies, communications, and of course, energy and sustainability. A few awards to our credit. And I would request people to ask me questions. Otherwise, I could go on and on. Yes.
Thank you, sir.
So, and Swapnil, when you say that you have diverted from 91% from landfill to 71%, one figure was there.
So we reduced the use of single-use plastic by 91% within our campuses.
Okay.
And all the so waste is an important aspect, right? So we all focus on CO2, we all say carbon footprint, but we do not look at the impact of what methane does on the environment, right? Methane is 25 times more potent than what CO2 does, right? So managing waste is an important aspect. There is waste segregation at source that happens in organic waste is treated on campuses. We have biogas plants, use food waste to convert it into biogas. This biogas gets into food courts, then we use these for cooking, right? We look at waste and means to treat inorganic waste and so on and so forth.
Swapnil, new buildings understood this way. What happened to the older buildings and how much time did it take to convert them?
So, and I was hoping that this question comes up. And Rajiv, if you can lift up the, that pressure on the timing, I would be in a better position. I would be in a better position.
I'm in a good mood today.
tell stories. So 2010 is when, or 2008 is when we started looking at new buildings, right? And these new buildings essentially had all the passive design considerations that you need to have when you construct a new building, right? So you orient the building right, you ensure that the wall to window ratio is less than 30%. You have light shelves, that allow for the daylight to come in. You have a view pane and a glass pane that allows for light to come in but restricts heat gain. You essentially look at the kind of glass that you use. So you go back to the overall heat transfer coefficient for the glass and ensure that the watt per square feet of what your energy consumption should be is within the design limits, right? So this is all that you do for a normal construction building. However, when Infosys first started creating its huge footprint, they started creating and building crazy buildings, right? Huge glass buildings. One building looks like an egg, the other building looks like a pyramid, and so on and so forth. And these are huge energy guzzlers, right? We went back and re-looked at ways and means to reduce the heat gain within these buildings, and we did this by either changing the glass on the facade. So there were facade retrofits that happened while retaining the shape of the buildings. We did facade retrofits, and when we did facade retrofits, within the shell, within the facade, we had buildings or we had structures that were primarily aligned to the newer design buildings. So while we were not able to leverage the efficiencies of daylighting coming into the space, we were able to leverage the air conditioning efficiencies that we brought in as a result of these facade retrofits. Pune happens to be a beautiful campus with beautiful weather. I don't have air conditioners at home. I stay at a hotel of a mountain, sir. But in Pune, we changed a glass food court, removed the lower portion of the glass and the upper portion of the glass, and ensured that we use natural convective currents to remove the heat. It not only removed the heat, but it also improved the overall acoustics within the space. So it is thermal comfort, visual comfort, acoustic comfort, as well as, so this all impacts wellness of our employees, right? The average employee strength within average employee age at Infosys is 28 to 30, and that's what we really need to cater to. That was primarily on the older buildings. Retrofit happens to be a major part of what we do. Our data centers, and there was a question on data centers. Our data centers run at a PUE of 1.12 operational, right? For each building, we have close to 30 different KPIs that we manage and monitor. Energy performance index of our buildings ranges in the range of 67 kilowatt per meter square per year to anywhere between 110, depending on the location, depending on how the building is constructed, and so on and so forth. We monitored every single aspect of water by virtue of putting smart metering in place, right? So end-use consumption strategies where you look at sensor taps, using those restrictors and flow meters and stuff like that is all in place.
This is really fascinating to hear all this. So just wondering, we earlier also heard about this. So this scaled up implementation of green practices, has it paid back for itself? And if yes, then the question is, then why not everyone is doing it?
Yeah, so I get these questions around cost a lot of time, and these questions are primarily very common as to, are green buildings expensive or have they paid back, right? And that's the reason why I was kind of not very happy when we were just discussing the ROI model, right? Our buildings have paid back for themselves. Green buildings cost at least 25% lower, or rather 21% lower than a normal building that you would construct, right? I have data to prove these numbers, data that I have sourced and the projects that I've run at Infosys. And when I say 21%, this is This is the way in which we construct our buildings, right? You have luxurious buildings. You could do away with a lot of stuff that you essentially should not be putting into a building, but even after putting that, it's close to 21% lower. Now, why is everybody not doing it? Primarily because people do not want to really invest the time and the effort, to design an efficient building, right? For the project that we just saw before I started, right? The company had thought through on that. They wanted to do, geothermal cooling, and they actually designed the entire concrete structure in the basement of the factory to do that, right? So an integrated design methodology is something that is the need of the hour. You just cannot create a structure first and then say, oh, I'm going to put in the most efficient air conditioning equipment and I'll be, a sustainable building. No, it cannot happen. You have to think about the materials that go into the building. You have to think about the insulation that gets into the building. You have to think about what the size of the window should be. You have to think about the depth of of the light shelf. You have to look at how the light shelves are integrated in the facade of the building. You have to look at so many different things, right? This knowledge, though slow, is picking up, and we see, folks like Terry and IGBC and USGBC actually running this. They're very focused on green building principles. Now, green building principles only focus on the operational aspects of the building. Right? To be truly net zero, you also need to look at the embodied aspect of. So, if you look at the total carbon footprint, it has two compositions: the embodied carbon and the operational carbon. There will always be a residual carbon because you are operating your building. But when you do your initiatives around being net zero, you have to tackle both the embodied and the operational carbon, and that is where carbon offsets really play an important role.
So, just one observation. None of your buildings are without air conditioning now. Everything is 100% air conditioned, including the original Bangalore campus, which I believe at one point of time was not air conditioned. When it was originally.
The two buildings are still not air conditioned.
Okay, so with a small minor exception of that, right?
Yeah, right.
So, has it ever come to your mind that can we have designs of buildings where we can have an option of running the building without air conditioning, right? So just like, for example, borrowing a page from Praveen's thing, that if you have trees, which is providing a cover to the building, that the heat loads will come down. But since our buildings tend to be very tall and very deep, there is no chance that the radiation load can be prevented.
You're right. So if you visit any Infosys building on a Saturday and a Sunday, these buildings are operated without air conditioning, right? We operate at 24 plus minus 1, and it's never 1, with a relative humidity of anywhere between 55 to 65%. The density of people working in a building is high for us, right? So that's one hindrance. Having said that, aspects like radiant cooling, and that's where smart building technologies come into play. The only thing that we have to monitor when we are doing radiant cooling is the dew point, so that the condensation doesn't happen. Until the time you are able to manage that, you can actually elevate the temperature from 24 to 27 to 28 to 30, but ensure that your fans are running so that the convection helps, right? So you use all the three modes of heat transfer basically, right? It is so we've transitioned from radiant slabs to radiant, to radiant baffles now. There was an intermediate, so we use chilled beams as well. Radiant panels, didn't have much success with radiant panels for whatever reason, right? Because the installation methodology was not great and all that. We have our own patented Infosys radiant baffles. So it's like the fins of the Luna that we used to drive when we were kids, right? So the fins, right? So these fins are essentially radiant baffles, and they cool the air around you. The idea is to kind of split the heat loads and treat them differently.
So just sort of a continuation to what you were explaining earlier, like in terms of just 21% cheaper of this newer sort of concept that you are building up. I mean, this number is really fascinating in the sense that you are talking about a lot of the smarter devices. You know, a lot of times you use the smart meters and sort of smarter sort of sensors and so on and so forth that you are putting in these new envelopes. And B, on the other hand, you're saying it's still sort of 21%. So I think the question one which comes to mind is that what sort of life cycle you're considering when you're saying sort of 21%, you know, and is there sort of a ballpark of payback in terms of years as well, like, you know,
So 6
5,
years,
7, whatever.
don't hold me to the number, right? But 6 years is essentially when the building pays back for a 5 lakh square feet worth of space. In Pune, if you come to Pune or Google software development 10, block 10 and SDB 10, these are the two largest HVAC experiments in the world. One has a technology that has radiant cooling, and the one has chilled beam installation. These two buildings are identical to the last extent. Then on the same chiller plant, and this is served by one chiller plant, right? On the same chiller plant, we have a 24/7 operational BPO building. So the BPO building, 5 lakh square feet, will operate 24/7. So what we do is we achieve a total tonnage balance at each of the building level to be able to see the KPIs that they are delivering. Now these buildings have different operational aspects, right? So a BPO building runs 24/7, and SDB 10 will have a data center in it, and SDB 11 will probably have only the number of occupants. The heat load more or less is consistent, but because the usage patterns are different, we are able to monitor it using smart controls. That's point number one. And then a building will pay back in 6 years roughly. However, a building typically will last for 60 years, and that's what is our design philosophy. The first retrofit intervention happens in the 12th year. So if I have to change, and I don't take into account aspects like lighting, right, because they are, but if I have to look at capital expenses, right, so that happens on the 12th year. So the entire benefits for putting in these smart systems is roughly to the tune of what I achieved for 5 years, right? So the kind of efficiencies that I'll translate into cost to the tune of 5 years is something that I look at 5 to 6 years.
Thank you, Swapnil. Thank you so much.